Hello students, welcome to Study Out. This question is from physics, topic ray optics. Here in the question it is given that double convex lens are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. What is the radius of curvature required if the focal length is to be 20 centimeter? So let's understand this question with a figure. As you see here, we have a double convex lens. This we consider as the first face of the convex lens, and here this is the second face of the convex lens. So based on the first surface, our radius of curvature will be represented as R1. This is our R1. And based on the second surface, here is our R2. Now if we see the sign convention, we know that right side is considered as positive and the left side is considered as negative. So based on that, the sign convention of R1 is positive and R2 is negative. Now according to the question, it is given that the focal length is 20 centimeter. So we write it as F is equal to plus 20 centimeter. Because for a convex lens, our focal length is here. It is on the positive side, so it is plus 20 centimeter. And the refractive index is given as 1.55. So if we consider this as refractive index N1 and this is refractive index N2 of the glass is equal to N21. It can be written as mu21. Its value is equal to 1.55. Now based on this information, we have to find the radius of curvature. This R1 and R2 value we have to find. And in the question, it is mentioned that both the faces having the same radius of curvature. So it means that magnitude of R1 and R2 is equal to R. So the magnitude is same, but the sign will change. So to find the value of R, we have to find this R value. We are going to use the lens maker's formula. This is our lens maker formula. 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. And in the question, focal length is given as 20 centimeter. So we write 1 by 20 centimeter is equal to refractive index is given 1.55 minus 1 bracket. This is 1 by R and it is positive sign minus 1 by R with a negative sign based on the sign convention. Now further 1 by 20 centimeter is equal to 0.55 and here it is 1 by R plus 1 by. Further solving 1 by 20 centimeter is equal to 0.55 bracket 2 by R. R is equal to 0.55 into 2 into 20 centimeter. So from here R is equal to plus 22 centimeter. So this is the answer of this question. The magnitude of the radius of curvature is 22 centimeter. If we have to find for the R1 and R2, only the sign convention will change. Means here we can write plus 22 centimeter and this side we write minus 22 centimeter. But the magnitude is same. I hope you understood this question properly. If you have any question, any doubt, you can mention me in the comment box. Thank you so much.